Hello, welcome to another project on the 21 and 21 project in 21 days. We're doing the final project in the disaster recovery series using Pulumi this time. Pulumi and Cursor. Cool, so we're going to be doing a multi-cloud setup for disaster recovery with Pulumi. We build a three-way failover across AWS and GCP, entirely managed with infrastructure as code using Pulumi. Very good. So a quick 30-second summary. Imagine your production application runs on AWS App Runner across two regions. That's a good start, but what happens if AWS itself has an outage? Your multi-region setup becomes useless because it's all a single cloud. True disaster recovery means multi-cloud, and manual deployments mean configuration drift. One region drifts from another, and suddenly your identical environments aren't identical anymore. You'll solve both problems by managing AWS and GCP infrastructure with Pulumi. Every change is version controlled and reproducible. Every deployment is consistent across regions, or across clouds, sorry. How do these pieces fit together? In this project, you'll create a multi-cloud failover system with the same web application running on AWS App Runner and on GCP Cloud Run, all managed with the same infrastructure as code using Pulumi TypeScript. So we can see here an outline of the explaining how these pieces fit together, sort of an architecture diagram style. You've got the user in the browser accessing CloudFront, which has US East 1, and then it has GCP Cloud Run as its backup. Because we're keeping this project free, we haven't set it up such that there's US West 2 as a fallback before GCP Cloud, because you need to pay for that more. So yeah, let's get into it. Why infrastructure as code? So that's what Pulumi provides. When you deploy infrastructure manually through cloud consoles, there's no record of what you did. Team members make different changes in different regions. 6 months later, your identical environments have drifted apart. Infrastructure code solves this by defining your infrastructure in version-controlled files. Every change is tracked, reviewed, and reproducible. If something breaks, you can see exactly what changed and roll it back. Pulumi takes this further by letting you use real programming languages like TypeScript instead of domain-specific languages. You get loops, conditionals, and IDE autocomplete for your infrastructure. You don't need prior Pulumi or multi-cloud experience for this project. This project teaches you how to import your existing infrastructure to deploy across different cloud providers and configure the CloudFront failover. Cool. Okay, so if you're not sure if this project's right for you, you can click here to use the Ask AI feature, but I think it's right for me, so I'm going to go ahead. What you'll create, so Pulumi TypeScript code, managing your AWS and GCP infrastructure from a single codebase, multi-cloud failover with CloudFront that automatically switches traffic between AWS and GCP. And then in the second mission, we'll be doing a CloudWatch dashboard built with Cursor and Pulumi. It'll show DR system health at a glance. That's disaster recovery. Prerequisite, this project does build on parts 1 and 2 in the series. So you'll need an App Runner services, or you'll need App Runner services on US East 1 and West 2, plus a CloudFront distribution with Origin failover. There's setup guides. I will do this quiz at the end. The setup guides down here, and we'll be walking through the high-touch version, the step-by-step guidance. There is lower variants of the guidance steps here. Welcome to walk through those too. But we're going to go through the step-by-step guidance here. The catch-up steps are somewhere down here. Here we go. We'll get to those in a minute. So what are we doing in this project? In this project, I'm going to use Pulumi to run a multi-cloud setup. Multi-cloud disaster recovery is important because if an entire cloud provider like AWS goes down, that's could both US East, well it would be. US 2. Our failover setup switches to using GCP. Infrastructure as code helps by giving us quality of life. We could say like by letting us write in common languages. TypeScript. Right. Our infrastructure in common languages. This gives us like quality of life stuff like loops and other things which you wouldn't get otherwise. Cool. So step 1, import existing AWS infrastructure into Pulumi. Time to bring your existing AWS infrastructure code under code control. You'll install Pulumi and import your App Runner services into TypeScript code. So in this step, get ready to install Pulumi CLI and initialize a TypeScript project. Import your App Runner services, US East 1, US West 2, and verify your code matches the deployed infrastructure. In this step, I'm going to install Pulumi and initialize a TypeScript project. Importing infrastructure means pulling configs from AWS. In our case, this is useful because it allows Pulumi to configure to manage these with coded infrastructure. Cool, so in this step I'm going to install Pulumi and initialize a TypeScript project. Importing infrastructure means pulling configs from AWS. This is useful because it allows Pulumi to manage these with coded infrastructure. Okay, so we're going to check we've actually got this set up, this being the previous two projects. If you haven't, then you could follow the I haven't done project 1 and 2 panel, or tab, sorry. So before we start with Pulumi, let's verify your App Runner services from parts 1 and 2 are still running. So go to AWS Runner console and make sure the region is set to US East on the top right. So I will just open this up in my browser over here. So US East 1, we see that. That's cool. Now we can also check US West 2. Nice. Good. Okay. So I see my services running. That's a good start. If you don't, that's also fine too. You either haven't done the projects 1 and 2, or you've deleted the stuff there, which is totally okay. If you haven't, you can go through the setup steps here, or check out the actual projects on on our page, on our site. Cool. So what do you see? I see my service app running. We'll go down here. So we're going to right click this and click copy link address, and then we'll save it here. We'll use this later on, and the project guide will give it back to us when we need it. So we'll switch back to Oregon or West, and then same thing. Cool. So I'll open up PowerShell terminal, and I'll run that. So we can see that Pulumi is actually installed for us. So we'll go down here. I have a version number. If you don't, there's steps as to how to install it for Windows and Mac. Pretty simple. But we're going to go down this path. Okay, we're going to open up Cursor, and then we'll open our project that we've been working on, which is multi-region app from the first 2 projects. Cursor takes a minute to open on my laptop. Apologies. Cool, so opened. Cool, I'll put this over here as well. So we can see I click there on recent projects, but I'll select open project, go to desktop, and select multi-region app. Cool. Okay, now I'll switch to the Windows tab here, and then you can go up there and turn on your terminal, or you can do Control apostrophe to open the terminal here. Awesome. So we just created a new subdirectory called infrastructure, and we've changed directory into it. So why a subdirectory? Keeping your infrastructure code in a separate folder alongside your app code is a common pattern. It keeps your project organized, so the app code stays in the root, and the IAC code lives in infrastructure. This makes it easy to manage both together in one repo. So now we're going to configure Pulumi backend. Pulumi needs a backend to store infrastructure state. For this project, we'll use Pulumi Cloud free tier. Why does Pulumi need a backend? Imagine running Pulumi up. That's the command that pushes, deploys all your stuff. And Pulumi has no memory of what it created before. It might try to recreate everything. The backend stores a state, a record of your deployed resources, this is how Pulumi knows I already created this app runner service, no changes needed. Pulumi Cloud stores the state securely in the cloud, and it's free for personal projects. Cool, so we'll go create a Pulumi account. Well, I already have one, but you would go here, you would go create an account. If we go this, and then I'd go with GitHub here. That's what we're going to do with this project, but I've already created an account, so yeah, we can go sign in with GitHub. Yeah, so that's all you need to do on that front. Cool. Cool, so it logged in, because I was logged in on my browser. That worked pretty quickly. Just pressed enter and then logged me in. But if you're not logged in on your browser, then it might pop this up, and then you have to click GitHub to log in. Cool, we get a little welcome to Pulumi message there. If your browser didn't open, you can copy the URL it gives you here. If you manually authenticate, that may work, or will work perfectly fine. Cool, so now we're going to initialize, just clear this console. We're going to initialize a new Pulumi project called AWS TypeScript. Also using AWS TypeScript. So what is Pulumi new? This is like an npm init initialization for Node Package Manager, but for infrastructure. It creates a starter project with everything you need, a TypeScript config, the AWS libraries, and an index.ts where you'll define your cloud resources. You'll fill a few details, like the project name and AWS region in shortly, and Pulumi handles the rest. Cool, so project name, go with that. I've already done this project, so I'll just call this the same thing with an underscore. I guess we can see. Then stack dev's fine, and then yep, select npm, and then yep, region is US East 1. Cool. So Pulumi will create the project infrastructure. There's inside of the infrastructure file at the moment, or folder, sorry, the subdirectory. It will create a index.ts, a pulumi.yaml, and package.json inside of it. Yeah, so it's just installing dependencies now. It's running npm install. That shouldn't take too long. There's the node modules folder. So that's indicating that's working, which is great. Yeah, this shouldn't take too long. It took me about 45 seconds last time, so yeah, we'll see how long that takes now. Cool, so that took 57 seconds, but that's all done. So we're good to go. What does a Pulumi stack? Stack is an isolated, independently configurable instance of your Pulumi program. Think of it like environments. So dev, staging, prod, stacks all have their own configuration. For this project, we'll be using a single stack, dev. Cool, so I'll upload a screenshot of this. How did you initialize your Pulumi project? I created a Pulumi project by running, what was the command? I think it was Pulumi. Something like that. The stack name I chose was div Pulumi stores state in the backend infrastructure. So how did you initialize your Pulumi project? I created a Pulumi project by running Pulumi new TypeScript -AWS. The stack name I chose was dev Pulumi stores state in backend infrastructure folder, in the backend infrastructure folder. Cool. Okay. So import App Runner service US East 1. So now let's import your existing App Runner service from the primary region. This tells Pulumi to manage the existing resource without recreating it. So let's go to the App Runner console again. We have that here for US East 1, I believe. Oh, switch back. So we'll have to open this, and then we'll copy the ARN here. We'll just paste that in. So now we're going to import this resource into Pulumi. So we'll click copy there with our ARN number in it, or ID. And then we can go here, and I'll paste that in. We should get the opportunity to say yes or no, and details and explain in a minute. So what does Pulumi import do? Think of importing as adopting an existing resource. Pulumi reads what you've built in AWS and generates TypeScript code to match that. That matches it exactly. The magic, your infrastructure stays untouched, no recreation, no downtime. This is how teams migrate infrastructure as code without starting from scratch. Cool, so you can see that created some code here. Let's copy this. I have had Pulumi generate incorrect code before, but I think this is okay. So I'll switch over to the index.ts file. That's inside of, so not index.js.ts, which is inside of infrastructure, and I'll paste that in there. So this is the code required as infrastructure to run the US East 1. So there's some stuff here for the import failed. So the ARN is incorrect. AWS credentials aren't configured. The resource is in a different region. Make sure your Pulumi stacks AWS region matches where the resource lives. Cool. Now I'll just do the same thing for West. So I'll switch back to West here. Okay, that's a bit of a problem. There you go. So I'll copy that ARN in there. Copy this. And then clear this again. Just paste that in. Same story, very similar code that it puts out. Just let that run for a second. Cool. And I will copy the import statements and I'll explain what's going on there in a second. So I'll just click close on that. So I'll paste it in, but you'll see that these imports imports belong at the top of project, so I will shift those up here and check there's no repeats. So that's a repeat there. So is this, and so is this. So I'll get rid of that. Get rid of that. Oops. Yes, there. Cool. Yeah. So delete the duplicate import statements. If you've copied them, you could also just not copy them, but yeah. Alright, so now we're going to import CloudFront distribution. Now let's import your CloudFront distribution that routes traffic between regions. So we'll go back to the CloudFront console. These are all links, but I'm using a different Chrome profile, so it will just go here. So we'll go to CloudFront. We'll go to our distribution that we're running things on. What's that? Cool. So we'll just copy this ID from here. You could totally copy it from here as well. We'll just copy that, paste that in there, and then we will import this distribution as well. Just close that for now. Clear this and then import that. This can take a minute to run through and do, but that's all good. I didn't have this on my screen. But yeah, same command. So, well, the same import command with our region, and then just selecting yes, and then it will give us some code. And again, I'll copy this block at the top. Not that we need to, but just good to show off what's going on. So I'll copy it there. Might have even created a bug for us. That's fun. I think that's just a duplicate. Yeah, that's a good example of Pulumi creating something we don't want. We actually look to check that is not just a copy and pasting bug. Yeah, interesting. Okay. Anyway, we've got our, check where the import statements are. Yeah, cool. So deleted the excess import statements again, and yeah, so we're all good. Awesome. So we'll open up the terminal and we'll run Pulumi preview. Okay, that's my mistake. We need to be in the infrastructure directory. Then run it. Cool. So what is Pulumi preview? Preview is a dry run that shows what Pulumi would do if Pulumi up ran. So you can see some changes there, which is good. It compares your code to the current state and shows planned changes, create, update, delete. No changes mean your TypeScript code exactly matches what's deployed. Well, sorry, not is exactly matches. Your TypeScript code exactly matches what's deployed. The goal when importing an existing infrastructure always, yeah, that's the goal. So always preview before applying changes. Cool. So let's upload a screenshot of a successful Pulumi preview. How did you verify your inputs were successful? I imported my App Runner services by running the Pulumi import command for each AWS App Runner instance and the CloudFront. The Pulumi preview command showed 2 changes, 3 unchanged. This confirms that my changes have been pushed, so to speak. So how did you verify your imports were successful? I imported my App Runner services by running the Pulumi import command for each AWS App Runner instance and the CloudFront distribution. The Pulumi preview command showed 2 changes, 3 unchanged. This confirms my changes have been pushed. Cool. So now we're going to add GCP Cloud Run deployment. Now you've got AWS locked down. Now let's make sure your app is truly unstoppable. In this step, you'll deploy to GCP Cloud Run and bring it under Pulumi's management. By the end, your app will be running on 2 major cloud providers. So why multi-cloud? Think of it as a backup generator for your house. If the main power goes down, your backup GCP kicks in. Multi-cloud spreads your application across different cloud providers. So if AWS experiences a complete regional or global outage, your users won't even notice because GCP keeps serving traffic. The trade-off is complexity, which is exactly why we're using Pulumi to manage it all in one codebase. So in this step, get ready to set up GCP credentials and enable required APIs, deploy to GCP Cloud Run using source deploy, import Cloud Run service into Pulumi, and update code to detect GCP environment. What are we doing in this step? In this step, I'm going to deploy GCP Cloud Run, which will allow me to have a multi-cloud setup. Multi-cloud is important because if AWS or another cloud provider has a regional outage, global, the entire app would be down. I'll import it into Pulumi so I can host. So we can add the GCP Cloud Run instance to our host or to our infrastructure as code. What are we doing in this step? In this step, I'm going to deploy to GCP Cloud Run, which will allow me to have a multi-cloud setup. Multi-cloud is important because if AWS has a regional outage or global, the entire app would be down. I'll import it into Pulumi so we can add the GCP Cloud Run instance to our infrastructure as code. Cool, so let's set up GCP credentials. So first, let's check if it is installed. We're going to run this command. I think I've got a terminal open where I ran the command before. There you go. Give it a second. There you go. So that stuff's set up. If you see CLI install, which is this, then you're good to go. If not, there's some steps here to go and set this up. Yeah, just a standard install wizard for Windows, and you can use brew to install it for Mac, but we're working, so we're good to go. I can run this as well. We can log in, although I think I'm already logged in. Cool. We're now authenticated with gcloud CLI. Nice. Yeah, if you press it and open, there's some steps here. And definitely reach out to the community or use the ask feature here. Cool. So now, depending on where you're at, if you have a GCP project, you can continue down this path. If you need to create one and you already have an account, there's some instructions here. And if you don't have a GCP account and then you don't have a GCP project, there's some steps here as well. There's a free trial, so it's you don't have to pay anything for it. But yeah, just follow these steps here. But I have a GCP account, I have a GCP project, so we'll go down this way. All right, so let's go to this here. We're on GCP Disaster Recovery Project. I've set this up specifically for this, so we're just going to use this. So we'll just copy the project ID here, we'll paste it in this, and then we'll copy this into our terminal. Cool, that's all good. We can confirm this was set by running this command. Cool, it's our project ID, so that's good. Cool, so now we're going to create credentials for Pulumi to use. This is actually a different login to what we were doing before. So why two logins? GCP has two types of credentials. The gcloud auth login authenticates you for running gcloud commands interactively, and gcloud auth application default login creates an application credentials ADC that tools like Pulumi can use to run stuff on your behalf. As a security best practice, your tools get their own credentials rather than using your own personal login. Cool, so now we're going to enable these APIs if they're not already. So we can run gcloud services enable run these three APIs. Shouldn't take too long. What are these APIs? These are three services. These three services work together like an assembly line. Cloud build .google APIs takes your source code and builds a container image. Artifact registry .googleapis.com stores that container image. Cloud Run googleapis.com deploys the run container. Extra for experts, why do I need to enable APIs manually? GCP disables most APIs by default for security and billing reasons, enabling them as a one-time setup. Once enabled, they stay on for your project. Now we're going to deploy to Cloud Run. So now let's deploy your application to Cloud Run using source deploy. This builds directly from your source code, no Docker file required. Navigate to your application source directory, one up, from infrastructure, so you can do like I just did there. If I was in infrastructure and run cd dot dot, it jumps back, and then we'll run this command here. So what is source deploy? Source deploy is Cloud Run's magic trick. You give it source code and it figures out how to containerize it. It uses Google Cloud build packs to detect your language, so Node.js, Python, Go, etc. Installs dependencies and build a project container. No Docker file needed. The allow unauthenticated flag makes the service publicly accessible, like your App Runner services. So that just means, look, you can, anyone can run this, run the URL and get to your site, which is obviously what you want for a public-facing site. So Cloud Run will detect your application type. It's going to build your container using Google Cloud build packs and push artifact registry, then deploy to run to Cloud Run. So note the service will output a URL like this one here, and we're going to copy this into our into this block here because we'll use it a bit later. But this can take a few minutes, so we'll just wait for that to complete. Cool, so that finished. Took a few minutes. Cool. So we see our service URL here. Let me copy. So just clicking on that, clicking copy, and pasting that in there. Yeah, it can take a bit of time, but that's okay. Yeah, the first deployment is slow because build needs to be set up in the environment. Subsequent deployments are much faster. It's taking more than 10 minutes. Check the cloud build logs. GCP console, build, and then history. Cool, so now we're going to update the app code for GCP detection. Your service app should display which cloud provider it's running on. Cloud Run sets the K-service environment variable, while App Runner sets AWS region. Cool, so now we can use Cursor to apply these changes. Just close that for now. Control L, send that prompt there. So we'll review the changes once that comes through. We can set up extra for experts. How does environment detection work? Each cloud platform sets unique environment variables that identify where your app is running. K-service is set by Cloud Run, K-native under the hood. AWS region is set by App Runner. By checking these variables, your app can display different messages or adjust behavior based on which cloud it's running on. This is essential for verifying failover is working correctly. Cool, so we'll redeploy now. Should be relatively quick. Shouldn't take too long, and then once that's finished redeploying, we can test this URL here. So building, deploying. Build a container. It's going to route traffic and set the IAM policy. Cool, so that deployed. We can head back to Google Cloud here. We can go to Docs. Go to the Cloud Console. We can search. I wonder what that is. Oops. So if we go to Cloud Run, we can see multi-region app there. check security. We can update this to allow public access. So again, I went from just the Cloud Console here to up here and just searched Cloud Run, and then selected multi-region app, which we just created. Then I selected security, and then I select allow public access, so people can join or open the website. So I'll just paste this link in here, and we can see that on our GCP link that this is now connecting, and we can see US East 1 and US West 2, so that's great. Cool. All right. So we can, if we go to the API route for region, we can see hello from GCP Cloud Run. So we know that's working. This is so we're directly accessing it from GCP. The failover hasn't activated yet, but we know GCP is running our app, so that's great. And it's not here because the code's not written to give to return the timings of these two, but it's being hosted here. Cool. So in just a few commands, you've deployed to a completely different cloud provider. This is the power of cloud native deployment. Your app doesn't care where it runs. If you've got a wrong response or an error, there's some information here you can use to go and fix that. Definitely go to the community if you're stuck. I'll use the ask feature. So we'll just take a screenshot of this. How did you verify your GCP deployment? I deployed by to Cloud Run by running. Just paste the command in here. The response shows that the Cloud Run instance has been deployed successfully. This confirms my app is running on Cool. So how did you verify your GCP deployment? I deployed to Cloud Run by running gcloud run deploy. Read out the whole command. The response shows that the Cloud Run instance has been deployed successfully. This confirms my app is running on that. So we're going to add GCP provider to Pulumi. So we're going to go back to the infrastructure directory. Why has Copilot opened? Go away. And then we're going to install Pulumi here. And then we're going to set two configs for Pulumi. So that's our GCP project and the region we're running the GCP project in. This shouldn't take too long. Cool. One package installed. Very good. So now we're going to paste these commands to set these two variables. And then we're going to run everybody's favorite import statement here. Oh, that's not an import statement, sorry, that's a services run. Now we're going to import. And this shortly will give us a a yes or no, and then it's going to give us some code, and then we'll go back and add that to the index.typescript file. And then that should be imported correctly, and our infrastructure should be in code. I accidentally pressed no. So it is. Just run it again. Select yes this time. Sorry about that. Hopefully it'll give us some code this time. Awesome. Okay, so we'll copy this to the bottom here. Hopefully there's no TypeScript errors, and I'll remove, actually we'll just, to be careful, we'll shift these to the top of our TypeScript file. That's already been included, so I'll get rid of that. No TypeScript errors here, so we're all good to go, so save that, and then we can close it. So we're going to verify the GCP import. Can open a terminal, go back to this one I guess. Just let me do that. No, okay. I'm not in the infrastructure directory. Cool, so we should see some stuff come through here. Shouldn't take too long. Cool, very good. Just that one. Take a screenshot of this. Then we'll place it in here. I imported Cloud Run into Pulumi by running this command. Now my Pulumi code managers. This is multi-cloud IAC because, oops, my Pulumi code manages all my, or both cloud providers for me. This is multi-cloud IAC because both AWS App Runner, East and West, and GCP Cloud Run East. I think it's just called US Central, are hosted together using Pulumi. How does Pulumi code manage multiple clouds? I imported Cloud Run into Pulumi by running Pulumi import blah. Now my Pulumi code manages both cloud providers for me. This is multi-cloud IAC because both AWS App Runner East and West and GCP Cloud Run are hosted together using Pulumi. Okay, cool. So now we're going to configure CloudFront for multi-cloud failover. Time to see your multi-cloud setup in action. You've got AWS and GCP running. Now let's connect them with CloudFront so traffic automatically fails over when something goes wrong. By the end of the step, you'll pause AWS and watch your app seamlessly switch to GCP. This is disaster recovery in action. So why CloudFront for multi-cloud failover? CloudFront's origin groups support automatic failover between origins. We've already set this up. When the primary origin returns an error, CloudFront reroutes traffic. Now we're just going to be setting GCP to our secondary origin. In this step, get ready to replace US West 2 origin with GCP Cloud Run in CloudFront. Update the origin group for AWS to point to GCP Failover. Import updated CloudFront configuration to Pulumi. Test failover by pausing AWS App Runner. What are we doing in this step? In this step, I'm going to configure CloudFront 2. Automatically failover for GCP CloudFront instead of US West 2. Failover works by checking what errors we're checking. I think it's by doing a health check on the primary origin. This gives disaster recovery because when the health check fails, traffic is routed to GCP. What are we doing in this step? In this step, I'm going to configure CloudFront to automatically failover for GCP CloudFront instead of US West 2. It's not GCP CloudFront, it's GCP Cloud Run instead of US West 2. Failover works by doing a health check on the primary origin. This gives me disaster recovery because when that health check fails, traffic gets rerouted to GCP in this case. So let's go to the console here. I have it open over here. Signed out. I'll sign back in really quickly. Just go to a two-factor authentication code. Cool. So we're on CloudFront here. Go to distribution. Go to the Origins tab. We click Create Origin. We're going to paste in our multi-cloud thing here, making sure that the HTTPS disappears. It will do it automatically, but it's good to think about. We're going to go and select the name as GCP Cloud Run and click Create Origin. See it there, that's good. Cross-cloud origins work seamlessly. CloudFront doesn't care where your origin is hosted, it just needs a valid HTTPS endpoint. Your GCP Cloud Run URL works exactly like any other origin. This is the beauty of using CDN for multi-cloud architecture. So now we're going to update the origin group. Stay in the origin tabs, find the failover group, select it and click Edit. Remove US West 2, and we're going to add GCP Cloud Run. Scroll down and click Save Changes. Origin group failover criteria. CloudFront monitors responses from your primary origin where it receives any configured error codes, 5xx, so others too. It automatically retries request on your secondary origin. This happens transparently to users. They just see a working response even if the primary is down. So put a screenshot of your origin group configurations. We can just do this whole thing here. How did you convert CloudFront for multi-cloud failover? I configured the origin group with what did I call it? I call it GCP Cloud Run origin. The primary origin is still US East 1. The secondary origin is GCP Cloud Run. Failover triggers when US East 1 is down. Could be paused like we're about to do shortly. How did you configure CloudFront for multi-cloud failover? I configured the origin group with the GCP Cloud Run origin. The primary origin is still US East 1. The secondary origin is GCP Cloud Run. Failover triggers when US East is down. Cool. So wait for CloudFront deployment. This will take a little bit of time. It's deployed. There you go. So verify Pulumi state. We're going to Pulumi refresh and then push the code again. So making sure we're in the infrastructure directory, you can run Pulumi refresh. Shouldn't take too long. I press no again, so this. Just run that again. Select yes. Cool, so 1 has been updated, that's great. Now we're going to run Pulumi preview. Cool, so that updated, that's good. Now we're going to go and test our endpoint. So testing the API endpoint, we'll test the /API/region endpoint, which returns a simple text response showing which cloud is serving traffic. The root URL serves as a latency test page, making direct calls to App Runner that won't show CloudFront failover behavior. So test all services are healthy. So if we run this with our CloudFront thing, we can see with everything up and running. We see US East 1, which is good. So if you see a GCP response here, that probably means US East 1 is down, but there's some troubleshooting tips here. And if you're still stuck, you can go to the community or use the ask feature there. Cool, so let's go on to the console now for AWS App Runner. And then we'll make sure we're on US East 1, which we are, good. And we can go into here and we can pause this. So once this is finished pausing, this should go to GCP, which means everything's working correctly. This should take just 1 to 2 minutes, so not too long at all. Cool, so that's paused. So if we refresh this page, we should see hello from GCP Cloud. So same CloudFront thing, now using just GCP Cloud Run to run it. So we see that, so we're good. So if you still see hello from US East 1, the service might not be paused yet. If you get an error instead of GCP Cloud Run, try running the service again. And if you're still stuck, you can use the ask feature here, or you can reach out to the community. I definitely recommend that. Cool, multi-cloud failover is working. This is production grade disaster recovery. What you just built is exactly how companies survive outages. Your application now has 2 independent failure domains, AWS and GCP. If AWS experiences a regional or even a global outage, your users are automatically served by GCP. This is the power of multi-cloud architecture, and you're managing it with all with Pulumi. So code with infrastructure with code, sorry. So I'll just take a screenshot of this. how did you verify multi-cloud failover is working? I tested by first running the CloudFront URL, expecting to see US East 1, then running it, expecting to see US, well no, GCP. Then pausing US East 1. Running it again, and expecting to see GCP Cloud Run. When AWS was, full stop. When AWS was paused, CloudFront showed that we were using GCP. This proves the DR setup worked because it is using the secondary origin in the origin group. How did you verify multi-cloud failover was working? I tested failover by first running the CloudFront URL, expecting to see US East 1, then pausing US East 1, running it again and expecting to see GCP Cloud Run. When AWS was paused, CloudFront showed me that we were using GCP. This proves my disaster recovery setup works because it is using the secondary origin in the origin group. Cool, so we can go and restore this now. And it should go back to US East 1. So once the primary origin is healthy again, CloudFront automatically routes new requests back to it, no manual intervention. This is the power of automated disaster recovery. Cool, so while we wait for that, we can look at the secret mission. So building a multi-cloud monitoring dashboard, your failover works automatically, but how do you know what's happening across your infrastructure? By now you've built multi-cloud failover that routes traffic between AWS and GCP, but to truly manage a production system, you need visibility. In the secret mission, you'll use Cursor plus Pulumi to create a CloudWatch dashboard that shows your entire disaster recovery setup at a glance. So your failover works automatically, but how do you see what's happening? Right now, you have to check multiple consoles across AWS and GCP to see the system's health. What if you had a single dashboard to show everything at a glance? So why do dashboards matter in DR? When an outage happens, you need an instant visibility. Is the primary down? Did the failover kick in? Is the backup healthy? A well-designed dashboard answers these questions in seconds. So in the secret mission, get ready to use Cursor to generate Pulumi code for a CloudWatch dashboard. Deploy the dashboard with Pulumi up. View real-time metrics for your cloud multi-cloud setup. Watch the dashboard during a failover test. We can see as well, this will go back to East 1, because this is resumed. What are we building in the secret mission? In the secret mission, I'm using Cursor to generate a Pulumi dashboard. The dashboard will show active instances. This helps with DR because I can look in a single location for all instances. All instances health. Cool. So what are we building in the secret mission? In the secret mission, I'm going to use Cursor to generate a Pulumi dashboard. The dashboard will show active instances. This helps with DR because I can look in a single location for all instances health. All instant health. What you're building, a CloudWatch dashboard shows App Runner active instances. When App Runner is running, you'll see 1. When you pause it during failover testing, you'll see it drop to 0 in real time. This is the same observability pattern used by Netflix, Stripe, and other companies running production systems. So generate dashboard code with Cursor. Let's get Cursor to generate this code for you. Open Cursor in the infrastructure folder and open the Cursor chat. And we'll send this prompt off. review the code Cursor generates, click accept to add it to your index.ts. So what will Cursor generate? Cursor creates an AWS CloudWatch dashboard resource that monitors your App Runner service using Pulumi interpolate to dynamically extract the service ID from your existing App Runner service. This means the dashboard will automatically connect to the right service. The widget shows active instances 1 when running and 0 when paused. Very good. So after this adds stuff to our index folder, file, we will be able to deploy it and see it working. Cool, so we'll make sure we're in the right directory, and then we'll run Pulumi preview. Cool, so we saw one change, that's great. Now we can do Pulumi up to deploy that. Let's try not select no this time, like I've been doing before. Select yes, and hopefully the deployment succeeds. If it doesn't, there's some steps here as to what we can do to fix that. Definitely reach out to the community or use the ask feature for any help needed. Then we can upload a screenshot of our dashboard. Might come back to that once you view it. Shouldn't take too much longer. Cool, so 3 changes, 4 unchanged, took about a minute and a half. So now we can go to our CloudWatch console. Then if we go to dashboards, should see multi-cloud there. Go to enlarge, there you go. You can see active instances going to 1 and then back down to 0. So I will just take a screenshot of this. How does your dashboard help with observability? I deployed the dashboard using Pulumi up command. It shows active instances. When I tested failover, the metric shifts between 1 and 0 instances active. So test during failover. Let's watch the dashboard trigger while a failover. This is exactly what a on-call engineer would do on an incident. Keep the CloudWatch dashboard open in one tab, another tab, open that and pause the dashboard. You'll see it jump from 1 to 0. That's what it did there. I won't do this live, but it's just this will happen. It will go from 0 to 1. And you can restore it and it will jump back to that. So mission complete. You've built an observability layer for cloud DR setup. Infrastructure as code. Your dashboard is now defined in Pulumi. Version control monitoring. Changes to dashboards are tracked by Git. Incident ready. See App Runner health in real time during failover. This is the same pattern production teams use. Infrastructure as code for everything, including observability. When the next outage happens, you'll know exactly where to look. Cool, so we're going to clean up resources now. So congratulations on completing the project. Your multi-cloud disaster recovery setup is yours to keep, and you can build on it in future projects. However, if you'd like to clean up to save costs, here are some options. So AWS App Runner, pausing, stop charges, GCP Cloud Run, scales automatically to 0 when all cost if unused. CloudFront distribution, pay by request, can be deleted if not needed. Pulumi stack, local state, removed after deleting cloud resources. So I'm going to keep the resources, I'm going to keep working on this, but you can definitely delete everything here, and there's steps to do that there. Cool. We might actually go and pause these. Cool, that's a wrap. Alright, let's do this quiz. So which Google or GCP service is used to deploy GCP Cloud Run? How does your CloudFront achieve automatic failover? By switching the origin CloudFront console during an outage, by continuously monitoring latency, by using DNS, by routing a request to a secondary origin when the primary origin returns a configured error. Looks right to me. What infrastructure as code IAC tool is primarily used in this project? Pulumi. Which AWS service is used in this project to deploy the application in the US East 1 and US West 2? AWS App Runner. According to the project, what is the key benefit of adopting a multi-cloud architecture for disaster recovery? Provides redundancy by spreading application across different cloud providers, ensuring availability during an outage of one. Simplifies infrastructure, allows for easier migration, significantly reduces overall cost. What is the primary purpose of Pulumi import? To create a new cloud resource from scratch using Pulumi code, to delete existing cloud resources, to preview changes, to bring cloud infrastructure under Pulumi's management without recreating it. With that one. Cool. Alright, well, that was this project. I really hope you enjoyed going through it. I certainly learnt a lot designing it, and I hope you learnt heaps going through it, and that's the end of the AI disaster recovery series. But stay tuned, we've got some Azure projects coming out soon, Azure with AI. So yeah, super keen on doing those. But yeah, I'm gonna head off now. Alright, see ya.